Okay, so that's first asking for what is the y-intercept right here. And so to figure out where the y-intercept is, you basically just let x equal 0. So I'll just do function notation over here. And so we'll get 3 times 0 squared over 0 squared minus 4. And so on top, you'll get 3 times 0 because 0 squared is 0. Same thing on bottom, we'll get 0 take away 4. And then 3 times 0 is 0. 0 take away 4 is negative 4. 0 divided by negative 4 is going to be 0. And so that's what we want to put for our first one right here. Then for your x-intercepts, you let y equal 0, but really what you do is you just basically look for what will cause the numerator to equal 0, because that would automatically do it, right? So basically what I'm trying to say is if you have any number, if you have 0 over any number, as long as that number is not 0 on bottom also, that will cause the whole thing to equal 0. And so that's what we're trying to do here. So you take the numerator, 3x squared, and we're going to ask ourselves what would make that equal 0. So you take the top part for this part right here and figure out what would make that equal 0. And it's going to be 0, because if you plug in a 0, 0 squared is 0, 0 times 3 is 0. So that one's going to be at 0 also. Now for vertical asymptotes, what you have to do on there is you look at your excluded values of the denominator. And so what that means is this time you take the denominator and set that equal to 0, because remember, we don't like to divide by 0. So that's what we're going to do here is we're going to ask ourselves, okay, what would make the denominator equal 0, because that value is off limits. And that's how you find your vertical asymptotes. So this is factorable here, so this is going to factor to x plus 2, x minus 2. And then when you take each one of these and set them equal to 0, you're going to get x equals negative 2, and you'll get x equals positive 2. So those are the excluded values that cause the denominator to equal 0, and those are actually your vertical asymptotes right here. Now, horizontal asymptote's a little different. You look at the ratio. I'm going to scroll down. I've got the equation down here. You look at the ratio of the coefficients, and if the variables have the same exponent, which they do, you go ahead and you just take the ratio of those coefficients. So it's going to be y equals 3 divided by 1, because I have a 3 up here with the x squared, and I've got a 1 with the x squared here, and that ratio is just 3 over 1. You want to go ahead and simplify it to a 3. And so you want to make sure and put y equals 3. Okay, so you need to have the y equals 3 with it because it is an equation. Now, just for the purpose of, for some of the other examples, let's say that that square wasn't there on the top. It was just an x to the 1 power. Whenever the power on top is smaller than the power on bottom, it automatically is y equals 0. So that's not going to happen here, but I just want to point that out because a lot of the other examples you might see something like that. This next part is just plugging these in for x. So I'll plug in a couple of them. So let's see. If I were to do f of negative 4, let's see what we get here. So 3 times negative 4 squared over negative 4 squared minus 4. And then let's see, 3 times negative 4 to the second power becomes positive 16. And then negative 4 squared is positive 16. Take away 4. 3 times 16 is 48. 16 take away 4 is 12. And then that actually will simplify quite nicely just into the number 4 right there. They probably won't all come out that nice. A lot of them will probably actually be fractions, okay? Especially dealing with the negative 1/2 and the positive 1/2. Those are going to be a little bit more challenging. Let me go ahead and do one of those, and then we'll look at the last part. So let's say we get f of, and it really doesn't matter if I pick positive or negative. What you'll notice is my only variables both have squares. So whether I plug in positive or negative, I'm actually going to get the same result. So actually, this would be a 4 also, since for negative 4, I got 4. I'll get the same thing for when I plug in positive 4. Same thing with negative 3 and positive 3, and same thing with the 1/2s. So let's go ahead and plug in 1/2. Doesn't matter, negative or positive, it's going to come out the same. So 3 times 1/2 squared over 1/2 squared minus 4. So whenever you square a half, you square the top and bottom, so that would become 1/4. And then on bottom, that would become 1/4 minus 4. Then on top, that's going to turn into 3 over 4, because I'm going to multiply the 3 to the 1/4. Now on bottom, I have to get an LCD. So I'm going to change that 4 right there into minus 16 over 4. 16 over 4 is the same thing as 4, but now I have that common denominator. So now I'm going to have 3 over 4 divided by 1, take away 16 is going to be negative 15 over 4. Then what we're going to do is you're going to have to do keep, change it to multiplication, and flip that right there. I'm kind of running out of room, but I'm just going to scroll down here, and then I'll have plenty of room. Okay, so I'm going to keep the 3 over 4, change it to multiplication, then I got to flip it to 4 over negative 15. So then what we'll do here is the 4's will cancel out. And then the 3 and the 15 can reduce down to 1 and a negative 5. So I end up with 1 over negative 5. And that's what I'm going to get for both of these. That'll work for both of them, okay? I'll let you go ahead and do negative or positive 3. You're going to get the same for those anyways. Okay, so to the graph, though, let's look at that. So what's going to help you here is knowing your asymptotes. So we have 2 vertical asymptotes at negative and positive 2. So I'm going to do a rough sketch down here, and then we'll try to look at which one's the right answer. So vertical asymptotes, just vertical lines at x equals negative 2, x equals positive 2. And if you look at all the pictures, that's about what I've got going on here. Okay. And then I have a horizontal asymptote at 3, y equals 3, which is, roughly about right here. Y equals 3. And so that kind of narrows, it can't be D because the y asymptote's in the wrong spot. Same thing with A. So we've narrowed it down to B and C. Well, that's where the points come in up here in your table. So at negative 4, I would be up at positive 4, which would be above the horizontal asymptote, because the horizontal asymptote's at y equals 3. Same thing over here at positive 4, I'd be up here at 4 up here, okay? And then let's see, at 1/2 and at negative 1/2, I'd be at negative 1/5, which is going to be down here roughly, right? Now, all these kind of look the same on the edge. Not always, but at least the ones we're dealing with, they're always going to kind of curve towards those asymptotes like this. That's what the asymptotes are there for. They're really just guardrails for your graph. Same thing with the one in the middle. So the one in the middle, it's going to kind of look like a parabola. It's going to have that kind of shape. It's not a parabola, but it kind of has that shape to it. And once again, it's got the guardrails. And so sometimes in the middle, the shape will actually look like this. It will actually look like this instead of kind of that parabola shape. So you kind of have to be careful. That's why you need to find 3 points, at least 3 points in the middle, typically. But yeah, so play around with this. I would kind of do probably a couple more of the similar examples just to make sure you get this down, and send me some more of these if you have questions.